Okay, we continue logical form. The rule of inferences is a logical form, lah, or sometimes we call it as a guide. Okay, this one is inferences, or sometimes we call it as a premises or hypothesis. Lah. Contain premises or hypothesis. Okay, and then a valid argument when conclusion is either true or false, and all the beliefs are true. And invalid argument are called fallacy. Fallacy ni later we see the fallacy is the ambiguity of the statement or hypothesis. Uh, Later we see that one. What is the uh, fallacy? And then later we see the nine rule of inferences. We have modus ponent, we have modus tollens, we have hypothetical syllogism, disjunctive. Okay, conjunction, we have constructive simplification, absorption, okay, and so on. This one is nine rule of inferences. Okay, do you have any questions so far? The- Tadi, okay. Okay, this one is a definition, is a theorem. Theorem is valid logical assertion which can prove using two main component. This one is by the axiom, and this one by the rule of inferences. Okay, this one is logical rules allowing the deduction of the conclusion that built from the premises or the hypothesis. Okay, and then we have uh, the axiom. The axiom, basically, the axiom is the statement that can be proposition, which is regarded as being established, accepted, uh, okay, and then you can infer either the hypothesis, either the statement or proposition is true or false. Basically, this one is more on the assumption. Statement, or sometimes we call it as the proposition, okay, which are given to be true. Okay, and then we have lemma is a pre-theorem, and then we have corollary is a post-theorem. This one sometimes we call it as a pre and post condition. This one is pre and post condition. Okay, okay, for the lemma is a pre-theorem, or a result which is needed to prove some theorem. Basically, in mathematics, informal logic and argument mapping. Basically, for the lemma is the generally is a minor proven proposition, which is used as a stepping stone to a larger result. Okay, for that reason, it also known as a helping theorem or auxiliary theorem. Okay, this one is lemma, helping theorem. Lemma sometimes we call it as a helping theorem. Okay, so this one helping theorem, or sometimes we call it as a stepping stone. stepping stone uh, to a larger result. Okay, this one is to prove the proposition. Please be reminded for lemma and corollary is the to prove the proposition. Okay, to prove the proposition. Okay, and then for corollary, corollary is the theorem of less importance, which can be readily deduced the previous, more notably on the proposition or statement. This one is deduction. We deduce the statement. For the lemma is we induce inductive. Basically, for corollary is the deduced statement for the post. Okay, okay, or result which follow directly from a theorem lah. Okay, and then corollary principle where harm cannot avoided, we are obligated to minimize the harm we can do lah. And then for the corollary principle, do not increase the risk harms to others lah. This one is post theorem that minimize the risk. Okay, use uh, the statement. Okay, basically this one is to okay to reduce the risk lah. Okay, ada soalan ke? Cindy, are you okay? Okay, this one is a rule of inferences lah. Is a combination of hypothesis. As you can see here, we have H1, H2 until Hn. And then we use conjunctive or conjunction. H1 and H2 and H3. And then, by the way, therefore, or it's followed that by three dots. Okay, this one is therefore as a conclusion. Yeah. Okay. Okay, this one is hypothesis. Okay, follows by the conclusion. Okay, we need to infer first and then we go by the conclusion. Okay. Okay, this one we have a rule of inferences that I have explained to you before this. We have nine. First one is addition. Later, I explain this one. Conjunction. We have modus ponens, modus tollens, and so on. One, two. Okay, for the addition, if P is a premise, we can use addition rule to derive. Okay, P or Q, P or Q. That implies P hypothesis. Okay, and then you see a bar. Bar some is called implies. Okay, and then therefore, okay, because we have three dots here. Okay. Therefore, P or Q, okay, is as a conclusion lah. Is we can use addition rule to derive. Okay, derive the addition. Okay, example. Let P be the proposition. He studies very hard. Okay, this one is example. Okay, example for addition. Okay, P we have proposition. Okay, he studied very hard. Okay, true. And then therefore, we can say therefore either he study very hard or he is very bad student. Okay. Okay. And then you can say either he is studies very hard is P, and then he is very bad student Q lah. Okay. Okay. That's we can conclude for this one. P implies okay implies P or Q lah. Okay. Therefore, either he is study very hard or he is very bad. Okay, like this. Najmi boleh kena Najmi? Najmi? Hilang dah. Asmaniza boleh? Asmaniza? Boleh. Kamu main game ke? Ya saya. Buat sendiri. Kita kita sign lah. Kita buat dia kita denote lah dia dengan apa? Dengan abjad. Okay. Lepas P mesti Q kan. Jadi kita buat P Q lah. Kalau kita nak buat A B pun boleh. Tapi ni nak tunjuk dia punya apa? Dia punya association dia. Apa? Relationship dia. Okay. Okay, and then number two is simplification. Simplification. Okay, simplification. If P and Q, P and Q is a premise or is a proposition, we can use the simplification rule to derive P. Okay, we want to derive the P. Okay, and then we can say P and Q implies Q, or we can say P and Q P and Q therefore P lah. Okay, or therefore Q. Okay, either one lah. Okay, first condition P and Q implies Q, or P and Q implies Q lah. Is either one you want to derive lah. For example, he studies very hard and he is a very best boy in the class lah, P and Q lah. Therefore, he studies very hard, or we can say that he is a best boy in the class lah. Either way, you want to derive the P, or you want to derive the Q, either one. Okay, this one is simplification. Ini tak payah tulis eh. Okay, you can choose either one lah. P or sometimes you choose a Q lah, based on the premises. And then number 3 we have conjunction. Okay, we can say H1 okay, hypothesis 1 P and hypothesis 2 implies conclusion lah. Okay, when we implies, basically we use the N. And for example, he studies very hard. P, he is the best boy in the class. Q. Okay, therefore, okay, you can say that he studies very hard and he is best boy in the class lah. You want to conjunctive. Okay, to derive the rules P and Q. Okay, first you need to look is what you want to derive. You want to derive here P and Q. First, you want to look the derivation rule. Okay. Okay, this one for the conclusion. As a conclusion, you can say P and Q lah. Okay. Okay, number 4 is modus ponens. Modus ponens. You can say that if P implies Q are two premises, we can use the modus ponens to derive Q lah. Okay, here we have P and P implies Q. Okay, we can say that P implies Q. Okay, P implies Q are two premises. We can use modus ponens to derive Q. Okay, we want to use the hypothesis that implies the conclusion. Okay, we have 1 and 2. Hypothesis 1 and hypothesis 2. P, we want to affirm. We eliminate the P. Okay, P and P. Okay, implies Q. Therefore, we have Q lah. For example, for modus ponens, if you have a password, then you can log into a Facebook. P implies Q. If you have a password P, therefore you can log on to the Facebook lah. Okay. Okay. Again, if you have a password, you can log on to the Facebook lah. Okay. Syafiq ni ada? Syafiq ni hilang dah? Ada. Okay, kalau macam yang saya bagi tahu tadi, if you have password, then you can log on to the Facebook. Which one is P? Which one is Q? Syafiq, cepat. If you have a password, can log into Facebook. Yang mana satu kita nak buat P, yang mana satu Q? Syafi'i. Hmm. Hmm. Yang ni P lah, yang ni Q. Okay. If you have a password, you can log into Facebook lah. Okay. Jadi P ni kita eliminate. Jadi therefore you can log into Facebook lah. This one is modest ponent. Okay, the other acronym for modest ponent is modest tolerant. You deny, you negate, and then we have hypothetical syllogism and disjunctive syllogism. This one number 5, number 6, number 7. Please be remember for modest ponent, you affirm the condition. For modest tolerant, you denies. Okay, you denies. Okay, for example, if you have a password, then you can log into Facebook. For modest tolerant, you can say that you don't have a password because you negate the queue. You cannot log into Facebook. Okay, boleh? Okay, yang ni untuk modest opponent, you have a password for P and Q you can log into Facebook. But in modest stolen that denies you cannot log into Facebook because you don't have a password lah. You negate the condition Here in the hypothesis. Okay, we have modest stolen okay, modest stolen you eliminate the P and then therefore Q lah. And then here you negate the Q first. Okay, and then we have P implies Q, and then you negate the P. Okay, negate the P. For example, okay, you have a password, you can log into Facebook lah. If Q, you can log into Facebook, you negate, you cannot log in. You cannot log into Facebook, therefore, okay, therefore, you don't have a password. Therefore, you don't have a password. Okay. And then here, if you see that you want P only, okay, you negate negate P implies negate Q lah. Okay. Negate P implies negate Q, and then you have P lah. Okay. Okay, and then number 6, you have hypothetical syllogism and disjunctive syllogism. Okay, for hypothetical syllogism, you have P implies Q and Q implies R. Are two premises. We can use hypothetical syllogism to derive P implies Q. Okay, we want to derive implication here for the hypothetical and disjunctive syllogism. Okay, for example, P implies Q. We have Q implies R. Therefore, P implies R. Okay, for example, if it is rain, I shall not go to school. P implies Q. And then if I don't go to school, I won't do homework. Q implies R. Okay, therefore, if it's rain, I won't need to do a homework. P implies R. Okay, this one is hypothetical syllogism. You want to derive P implies Q. Okay, we use the implication. Implication. Okay, and then we have disjunctive or. The ice cream is not flavored vanilla. Okay, for example, we have P and Q. Okay, the ice cream is either vanilla flavor or chocolate flavor. Okay, and then we negate the P. The ice cream is not vanilla flavor. Therefore, the ice cream is not a chocolate. Therefore, the ice cream is a chocolate flavor lah. For disjunctive syllogism, we can use to derive Q. This one is we want to derive Q. Lah. For this one, we want to derive P implies R. Make sure you know the objective. What is you want to derive. Okay, we have P or Q, and then we have negate P, and then we have Q. Lah. Yeah. If you have P, if you want to derive the P, okay, P or Q, you must negate the Q. Lah. Okay. And then you have therefore P. Lah. For example, P, kita ada apa? P, kita ada the ice cream is either vanilla flavor. So P or Q lah. Okay. Sekejap. Dia hang sekejap. Banyak sangat device buka. Okay, boleh nampak ke? The ice cream is either vanilla flavored or Q. We can have or we can say that chocolate flavor. Okay. And then for the P, negate P. You want to negate the P. The ice cream is not vanilla flavored lah. Okay, and then the implication implies therefore the ice cream is chocolate flavor lah. Therefore, we can say therefore the ice cream is a chocolate flavor. Okay, we have P and Q. We have negate P. Okay, and then kena ignore Q. Uh, Kenapa pula kita nak ignore Q? Kita nak ignore P lah. Sebab kita nak chocolate flavor. Faham ke? Tak faham. Faris? Tak faham kan Faris? Apa yang tak faham tu? Okay, kita nak tengok sekarang ni. Okay, disjunctive kan. Disjunctive. Sekejap. Dia pening sekejap. Kita ada P or Q and negate P that implies Q lah. Okay. That implies Q. Jadi kat sini P and Q kita akan jadi macam ni lah. Disjunctive P or Q. Okay, and then we have negate P. Therefore kita ada 1, 2, 3. Kita ada Q lah. Kita nak eliminate ni P. Kenapa kita nak ignore Q? Sedangkan dia punya implication dia adalah the ice cream is chocolate flavour. Faris boleh ke? Kamu faham ke tak ni ke kamu pening? Pening sikit. Kenapa pening sikit? Kita nak sekarang ni kita nak kita ada dua premises ice cream is either vanilla flavor or chocolate flavor. Or lah. Sekarang kita negate kan P, ice cream is not vanilla flavor. Okay. Jadi kita dapat Q lah. Therefore, the ice cream is chocolate flavor lah. Dan dia ada dua perisa je. Okay. Okay, and then we have a resolution. We have resolution. Okay, for the resolution, we have Q or R. We want to derive Q or R. Okay, and then we have P or Q and negate P or R. And then if we have P and negate P, we eliminate P. And then we have Q or R. Okay, in mathematics and more specifically on the resolution, on the discrete math, resolution or left resolution is the exact sequence of module used to define invariant characterizing of the structure. Okay, and then it is a rule of inference leading to refutation complete theorem proving for sentence in propositional logic or first order logic lah. Okay, sometimes we call it as a resolvent. Resolvent. Kita nak resolve dia. Okay, we want to resolve. Resolvent. Sometimes we name it as a resolvent. Macam mana je resolvent? Resolvent. Okay, because we have a P here and we negate. Okay, negate, we eliminate P lah. Okay, and then we have therefore, we have Q or R. Okay, this one is simplification. We have another example. Uh, P, it is below freezing. Q, it is raining now. Okay, and then it is below freezing and raining now. P and Q. Therefore, okay, we want to derive P. Therefore, it is below freezing. Okay, and then simplification is what you want to derive. You want to derive P. Okay, and then therefore it is below freezing. Yang ni kena tahu lah. Okay. Okay. What premises you want to derive? Okay, and then model exponent that mode that affirm. In other words, if hypothesis P is true here. Okay, and hypothesis P implies Q also true. Okay, I can conclude Q lah. Okay, I can conclude Q. Okay, that affirm P is true, P implies Q true, and then conclude Q lah. Okay, ni sama jugalah model exponent ni. Okay, kita nak affirm je dia punya result ni. And then model exponent, another example, Pn is greater than 3 and n power of 2 is greater than 9. And then we have assuming that P is true, follows by and P implies Q is true, then if n is greater than 3, it follows that n power of 2 is greater than 9. Okay, for the exercise, okay, we have hypothesis H, conclusion as C. Okay, we have hypothesis if it is rain today, P, then we will not have a barbecue today, negate Q. Okay, and if we do not have a barbecue, negate Q implies today, then we will have a barbecue tomorrow lah. R lah. Okay, we have a P, it rains today. Q, we will have a barbecue today, and R, we will have a barbecue tomorrow lah. This one is proportional variable. You can choose other variable like A, B, C also can. It's up to you. Okay. And then therefore, as a conclusion, we can say that P, it is rain today. Then we will have a barbecue tomorrow. P implies R. Okay. For the exercise, we conclude that P implies negate Q is hypothesis 1. And negate Q implies R is hypothesis 2. And then as a conclusion, P implies R is a conclusion. Therefore, P implies R. And then we have a step for H1. H1, we have P imply negate Q is H1. Q negate Q implies R is H2. And then we have hypothesis hypothetical syllogism 1 and 2. Okay, that's why we have P implies R. Okay, untuk hypothetical syllogism tadi macam mana? Macam mana Amira? Menurut Amira? Menurut Amira? Amira ada ke? Huda ada ke Huda? Apa dia? Macam mana? Apa yang dikatakan hypothetical syllogism ni? Apa dia? Tak faham kan tu? Ke kamu main game ni? Begitu? Kamu buat apa masak-masak? Tak apa pun nak faham. Apa yang kamu tak faham? Hypo tu kan saya katakan tadi apa? Kita nak derive P implies R kan? Tengok balik tadi. P implies R. Lepas tu kita ada dua step Kita ada dua premises ataupun hypothesis. Hypothesis 1 and 2. Jadi kita combine hypothesis 1 and 2 tu. Implies. Buang dah yang di negate. Yelah. Kita buang lah. Dan ingat dalam kita tengok model spawner, model stolen, yang ni hypothetical syllogism ni kita nak buang Q kita nak buang Q. Okay. Jadi we can say that we hypothetical syllogism hypothesis 1 and hypothesis 2 lah. Conclusion dengan therefore tu sama je. Boleh? Udah boleh dah? Tak apa-apa lagi. Aduh, macam mana nak bagi kamu faham ni? Tengoklah ni rules ni. Kan kita nak buang hypothetical syllogism ni. Kita nak buang Q. Jadi kita nak derive P implies R. Tak faham juga? Apa yang boleh Sekejap je boleh Kita nak derive ni. Lastly we want to derive P implies R. And then what we want to do, we negate Negate ni, Q ni. Kan nak buang. Okay, as a conclusion, therefore we can say that P implies R lah. Yang ni kamu semua kena faham apa yang kamu nak buang. Okay, and then validity of argument. Okay, kita rehat sekejap lah sebab ramai yang pening dah. Boleh